Here's my example one. Don't worry, I'm going to give you a nice big table with all of the sort of proper results and everything you need to sort of remember, okay? But when I learned to drive, when I got taught to drive, start again. When my brother got taught to drive, when he was like coming up to a certain kind of turn, it's like, okay, this is a 90-degree turn. You need to put your hands here and turn your hands exactly some number of degrees, and then you need to release this many and blah, blah, blah. And if you're turning right at like a roundabout, you turn left this many degrees, and then you turn this right this many degrees, and you turn left, and so on, right? And, sorry?
Is it the same for all cars? Because what if you change cars?
Good point. Now, here's the thing, right? It's not the same. It's sort of generally close. But the point is that when my brother learned that way, right, there's a danger to learning, this is exactly how it works each time, and then you just sort of formulaically apply it mechanically without thinking. So the way I learned was actually, I didn't know anything about you turn the wheel this much, or you go this and then that. My instructor, he just kind of said, okay, here we go. There's no one here you can kill, except for possibly yourself, and me next to you. But my seat has an airbag, so you'll be stuffed. Anyway, he said, look, just develop your sense of how it works, right? And then we'll add in the rules later on, okay? So that's what I'm trying to do here. So I'm just picking out specific examples, and we will get a big table of memorizable results later. I want you to try and see how it works. Okay? All right, coming back. Now, root 3 on 2. Root 3 is about 1.7, thereabouts, okay? So I think if you divide it by 2, that should be like 0.85 or something like that. Now, the range of cosine is 1, so I'm pretty close to the top. So when I draw in my line like so, I think that's roughly where it's going to be, okay? So I'm calling that y equals root 3 on 2, okay? Now, where's the first solution going to be? Think to your exact values. Your first solution for this equation is pi on 6, okay? Cos of pi on 6 is root 3 on 2, right? So that corresponds to here, which is not too bad. It's a bit off because that's meant to be pi, but you get the idea. Okay. Now, how do I go from that solution to all the other ones? Okay. Well, some of them are more obvious than others. For instance, we know that the period of cosine, just like for sine, is 2 pi, right? So if I go 2 pi radians from here forward, I'm going to land on another solution, right? So it turns out if you go 2 pi forward, you're going to land on this one, this solution over here. Okay. So pi on 6 plus 2 pi, what's that going to be? Not 7 pi. That's only 1 pi. 13 pi on 6. Okay. Now, you can see I've missed this solution. We'll come back to it in a second. Pi on 6, 13 pi on 6. I could go again, do the same trick. I'll land over here, and I'll get to 25 pi on 6, and I can do it again, and so on. Okay. So there's some of my solutions. I take this, pi on 6, and then I add 2 pi. So pi on 6 plus 2 pi, pi on 6 plus 4 pi, I guess pi on 6 plus 6 pi, and 8 pi, and so on. But you can see I've missed all these ones in between, right? So how do I catch them? Well, instead of going forward 2 pi, right, look at the symmetry here, okay? So you think about this is 0 to 2 pi, so that's sort of one lot of cosine. To get to this answer, I went forward pi on 6. To get the other one, because of this symmetry, I have to go backwards pi on 6, right? So here, 2 pi is kind of like my axis of symmetry. I go forward pi on 6 to get one answer, and I go backwards to get the other one. So this one's going to be 11 pi on 6, right? And then again, you can see the same trick up here. This is 2 pi. That was my axis before. This is 4 pi, right? So to get one answer, I went forward pi on 6, and to get the other one, I've got to go backwards pi on 6, right? So I guess that would be 23 pi on 6. Okay? So how can I roll it all together? Well, look at these odd lots of pi. 1 pi, 3 pi, 5 pi. Nothing's really happening around there, is it? Okay? Everything's about these even lots of pi. 0, 2 pi, 4 pi, that's where all the action is. Okay? So, how do I express all of the even lots of pi's and skip all of the odd ones? Right? Well, yeah, I'm gonna put the n actually out the front, because we sort of read it as 0 pi, 2 pi, 4 pi, 6 pi, right? Now, after you get to those even lots of pi, what did we say we have to do? You have to go forward your little angle and you had to go backwards. So forward and backwards is plus or minus, right? And then you take this little related angle and that's what you're going backwards or forwards. Don't forget we introduced this n, okay? So you've got to say what is n, namely an integer, okay?